Hi, I'm Brady Forrest. I previously was with O'Reilly Media, Microsoft, and Coastal Ventures. And currently, I'm with Highway 1, which is a new startup incubator in San Francisco. It's part of PCH International, which is a very large supply chain management company out of Shenzhen. Manages most of Apple's supply chain and a lot of other large startups, or large companies' supply chains, as well as some startups. And the incubator is currently in recruitment mode with our first class in the fall. Zach?
Yeah, cool. Hey, I'm Zak Hellmuth. I am one of the co-founders of a startup called Upverter. We've been around for about 3 years. We make engineering software that lives in the web browser. So it's kind of like if you took Google Docs and GitHub and you made it hardware and jammed it into a web browser. That's what we do. So people use Upverter to design schematics and layouts and pieces of hardware. We worked very closely with the Pebble guys and the Thalmic Lab guys to build the pieces of hardware that they did. We're also working with some bigger companies. We work with Sun Microsystems and Tesla and SpaceX to help them do some of the hardware that they do. That's what we do. Yeah.
So we are two software guys who are coming to hardware. And that's a general trend that, personally, I'm seeing right now in the industry, where there's a lot of folks who want to go beyond the browser, they want to go beyond the phone, they want to go beyond the laptop, and create special use hardware, and are kind of coming up against this roadblock of how do you scale, how do you turn your idea into a physical device that enables a new use case or a new sensor. And that's actually why I got into this new role and why we've created this incubator, which is to basically educate people. And you can see examples of problems all over the place right now. I, like probably many of you, am on Kickstarter all the time. And just this last week, a project that I backed over a year ago sent out their second delay. Now, this is a fairly well-known product development company, meaning these are people who make hardware for a living. They help others make hardware. And their own Kickstarter project is now delayed basically indefinitely. It's a project called the Insta Cube, which is a connected picture frame that can show your Facebook and Instagram photos. Fairly simple, theoretically simple device. And they had sent out a delay a couple months ago. I didn't think much of it because everyone delays on Kickstarter. That's okay. But then 3 weeks ago, they sent out a very terse 2-paragraph note that said, we have had a failing with our Asian manufacturer, and we are sad to say we will no longer be able to ship in July. We will get back to you as soon as possible. Very terse. I had a feeling that was someone's last email that they ever sent from that company. And then just this week, they announced that they are now looking for outside funding to help them fund their Kickstarter project. So the moral of this is hardware is hard, and it's not easier just because you have experience. You need to be prepared going into it. And although there are a lot of parallels between hardware and software, the capital expenditure is not one of them.
Yeah, well, so like the Insta Cube guys, so this was kind of a new story to me. So Brady and I were talking a couple of days ago, and we were kind of talking about what we were going to say when we got here. And so I started digging in on the Insta Cube story, and they had like 20 years of experience as like a product design company. Like they had a whole staff, they had buildings and infrastructure and experience designing hardware. And they've ran like 4x over budget, like 400% over budget. They burned through their Kickstarter money. Like hardware is very, very hard, and they've had a prototype for like a year and a half, something like that. So like they've had a real thing that they could show people that did what they wanted it to do, and going from that to like 4,600 of them has taken them 18 months and has killed the company. So.
I don't know if it's killed the company, but that project is not doing well.
Right.
So there are a number of differences between hardware and software, and one of the fundamental ones is that there is no AWS for hardware. Right now, or back in 2005, when AWS was created, it was very expensive to start a software startup. If you started scaling, you had to go and buy a CDN. You had to buy bare metal and have a large capital expenditure. So A rounds back then were several $1,000,000 just to be able to actually serve your customers. And Amazon Web Services completely disrupted that and cut the cost of starting a software startup drastically. And in hardware, that's just not possible right now. If you want to actually create something, you have to go through the product development phase, the design phase, then prototyping, and then actually spending hundreds of thousands of dollars to build out your line just to be able to ship to your first customer and start to build up your retail presence and get your first revenue dollars. Whereas with software, you can launch on your own couple of web servers and then more easily, scale up with AWS.
Right. Yeah. So one of the common problems that we see, so we work with about 11,000 engineers as a result of what we're doing at Upverter, and the largest problem that anyone has is they get to the end of a design cycle, they can produce a couple of boards and a prototype, right? So they order some PCBs, they 3D print an enclosure, they've got some real thing in their hands, and then it's the scale, right? It's the elasticity of AWS that Brady was talking about. It's like how do you go to 100,000 of those units, and you have to start talking about China or local manufacturers. You have to start talking about people assembling the product who aren't you. This is where Kickstarter commonly comes in, is people have a prototype, but they need to produce 100,000 of something or 10,000 of something. Followed the Pebble guys very closely as they kind of went through this journey. So they had the watches, and then they did their Kickstarter. They had 86,000 units that they needed to supply as a result of that Kickstarter, and the timeline just got pushed out. Like injection molding took like 3 months to do the Pebble, and that's when they thought they'd ship like the first units, and so that gets pushed out. You would inevitably have quality problems, the whole thing, and so that's a big thing that we see. It's just the AWS, the Heroku, the whatever you want to call it, the git push, git deploy for hardware just doesn't exist right now.
Can you tell us more about Pebble, like the behind the scenes of Pebble?
I can talk a little bit about it. So our involvement was as one of the development tools they used to design the hardware, like the hardware design files. So they used us for some of the schematics and some of the layout. They used SolidWorks to do all of the mechanical stuff, and so they had these kind of 3 files, right? They had a bill of material file, they had a circuit board file, and they had some solid model files for what the thing was supposed to look like when it got put in somebody's hands. And so that was, we helped them get to the point where they had all of those files in their hand. And so that's what they had. That's what they had when they did the Kickstarter. So when they were at the point of the Kickstarter, they had those files. They'd built maybe 100 of the watches at that point in time. They had them, in bits and pieces. They assembled a couple to do the video. And then, so kind of a couple of things happened. So first thing that happened is they blew over from $100,000 to $10 million. And that was, it was a great thing for the company. They raised a lot of money. That was a really good thing. But at $100,000, it was an amount of money that they could have done it with their previous manufacturers. They had relationships from when they built the Impulse watch. So this was the second product that Pebble had built. And they had relationships. They built about 5,000 of the Impulse watches. To do 10,000 or so watches was not a big deal with the manufacturers that they already had. But as soon as they were talking about doing 100,000 units, and actually taking that release and putting it in like a retail space, so like 1 million units, it was a very different manufacturer problem that they had. So they started working very closely with Dragon, and Dragon's Scott Miller, and it's a newish. I guess he's a consultancy. He doesn't do any of the manufacturing himself, but Dragon knows a lot of people in China. They have some of those relationships, and they started working very closely together to try and take those design files that Pebble was able to produce, turn them into things that were mass manufacturable in Asia. And what that means is, not everything you design in SolidWorks can actually be injection molded. Not every circuit board that you design in a CAD package can actually be populated by a pick-and-place machine. And there are a lot of modifications you have to do to make those things manufacturable. And so they started on that process. And that took them about 3-4 months to kind of go through and redesign the product for mass manufacturing. At that point, they started working with injection molders in Taiwan. So they were doing injection molding in Taiwan. They were doing the circuit boards in Shenzhen, I think. I'm not sure where the actual assembly happened, but then it all made it back to Taiwan, where the final assembly, like circuit board, enclosure, glass, into a box. They worked very closely with the packaging guys that did the Amazon Kindle to do a similar packaging. And the reason for that was just it was easier to ship. It was easier to stuff into a box and ship, so you had to pay less dollars to the guys that were putting them in the boxes before you put them onto the back of like a UPS truck. And then it took them, they had to ship to about 100 countries. So it took them another 3 months to figure out how you mail stuff to those countries. And so there was a bunch of countries that they couldn't mail to, right? They had orders from Iran, and you're not allowed to send stuff to Iran. And so they had to figure out all that stuff. But so that was kind of the 3 stages that it went through. They had a couple of really big problems. They had an operating system problem. And I don't know much about that other than the fact that it wasn't as extensible as they wanted it to be, and so they had to hold things until software was ready. They had an injection molding problem where under UV light, the screen looked cracked, and so the screen was fine, but it was just the pressure at which they filled the mold caused stress when it cured. And if you put it under UV light, you could see it. And so they spent months trying to fix that. You couldn't see it. Like the product looked fine under normal light. But if you had tinted sunglasses, or like you went out in the bright sun or something like that, you would look like your Pebble was broken until you take off your glasses or get out of the sun. And so they wanted to fix it. But they spent months on this thing that nobody ever knew was there, and it was like tweaking the velocity at which the plastic got sprayed into a mold, right? Like that was the design cycle time. And then they had some problems with the strap coming off and the punches. So they were doing metal punching, and they had to get the metal punching right for the strap. And those were the 3 big problems that I know they had. They still have some problems getting the color right. So it's an injection molding problem. They want it to be a particular color of orange, and just getting the blend of dyes right so that happened. Anyways, that's what I know about it. We were kind of around through the whole process, just helping them tweak design files to represent the changes, but that was kind of our only involvement in that. But very real, very hard. It took them about 9 months longer than they thought it would take them to go to mass manufacturing. And I think they were aware of that very early on, but part of it was like the marketing. How do we market this to the Kickstarter audience? Like, do we show up and say it's going to take us 2 years to actually ship you this thing, but we need your money today? Or where do you draw that line? And how quickly do you think you can ship it versus what are people actually going to pledge money towards? So they had some of those problems, but I don't know. That's the stuff I know about it, though.
That warning story aside, I think that crowdfunding is a hugely important part of the ecosystem.
Agreed.
However, the way I look at it is, whenever possible, try to have your ducks in a row first. So if you are going to go to market and you expect to be able to raise somewhere over $1 million, already have your partners lined up. Already try to have DFM, design for manufacture, DFA, design for assembly, parts ready to go, so that you don't have to do this rework ahead of time or after taking funding. Another success story, because I do regard Pebble as a success story, is Ouya. And Ouya was the Android gaming console. Roy and Julie had tried to raise a round a year ago and were unable to get any traction at all from VCs in Silicon Valley. So they priced it out, realized they could make a $99 Android gaming console, launched it on Kickstarter after taking a small angel round to just kind of get them through the summer, and ended up raising the second largest Kickstarter round of $8.5 million, and then raised another $1 million in post-Kickstarter sales on their own site, and were able to ship this past spring. They had started working with a product development group, Eve Bahar's Fuse project, which worked on Jawbone from the get-go in exchange for equity. And they had already enlisted with manufacturing partners. So they were ready to go from the moment they hit launch on Kickstarter. And were able to use the Kickstarter momentum to raise a large round from Mayfield, and to parlay that into retail space with Best Buy and GameStop, which is something that a small hardware company normally wouldn't be able to do right away. And now they expect to be shipping thousands per month as they go out to stores. So Kickstarter, Indiegogo, all those various crowdfunding sites, definitely a great place to get marketing and distribution and to prove out your idea. But hard to do if you don't have your ducks in a row first.
Yeah. So and I'll add to that the Pebble story around funding is actually very similar. So I went through Y Combinator with Eric and the Pebble guys, and they came out of YC and really did struggle to raise money. Were able to kind of on the steam of their first product and that little bit of revenue they had coming in from that still and some of the money they raised from angels out of YC, were able to get to the point where they had a prototype of the Pebble ready to go. And Kickstarter was and I don't know how public that is, but Kickstarter really was kind of a Hail Mary pass for them. It was towards the end. The product wouldn't have existed if they didn't Kickstarter it. And they did, and it's an insane success as a result of that. But so kind of what Brady and I wanted to talk a little bit about was just some of the differences between hardware and software. So and then kind of how to get started. What the support network looks like, what the support group is, how you get help. Us hardware folk are surrounded by 100 times as many software folk. Where do you get help building hardware, and then what does prototyping look like? And we thought those were kind of the things that would be valuable to talk about. So like on the getting started thing, I think we've talked a lot about it. Pre-sales and Kickstarter and all of that kind of stuff is probably the end of your product development cycle. So backing up from that. So you're going through a couple of iterations where you're actually building a real prototype. So, prior to that, you're doing some amount of design. There's probably an electrical component to it. There's probably a mechanical component to whatever you're doing. And the tools for all of that are, it's CAD instead of a text editor. But you're designing those files. You're getting to the point where you can build a prototype, and then you're probably going into an iteration cycle where you're tweaking the files, printing a copy, tweaking the files, printing a copy, and you're doing 1 to 10 of these at a time, right? And then, tools for that, like 3D printers, you're using CAD software. There are a couple of good high-speed circuit prototype services nowadays. They're not to the point of scale, like they're not the AWS yet, but they're you can get a couple of them made, right? They're the, like the Bluehost or whatever that you would have used in your basement 10 years ago kind of thing. So, Osh Park is very popular nowadays. Seed Studio does some good stuff. There's some guys out on the West Coast, Sierra Circuits. They do some really good stuff too. You're gonna pay $100 to $1,000 to get 1 to 10 of these things made, right? That's about what it's gonna cost you. So if you've got 10 grand in kind of seed capital, you can probably do 1 or 2 prototype cycles, plus pay for a little bit of food over a couple of months while you're getting to the point where you have that final prototype. So I don't know. That's kind of what that looks like, I think.
And using your local tech shop as your IDE, basically. Because your primary machines you're going to be using are 3D printers, aka rapid prototyping machines, and laser cutters for your enclosures. And then try and make it as close to the form factor that the user will be using as possible. Realizing it'll be shrinking down, but you want to make sure that this is a device, because it's hardware that you're interacting with physically. So it's not just the software user experience, how it connects to the phone, but it's also how you handle it. And you'll never learn that unless the customers actually play with it. And I was chatting with a company that's in an accelerator out in Cornell. That's kind of a laser tag type company. And they're not ready for manufacture at all, but they had to do customer testing. Well, it's laser tag. They couldn't just make 1 or 2. So they actually spent a week assembling 30 of these and then loaned them out to fraternities for them to play laser tag with, which sounds like kind of fun. But when you start to go from 30 to 100, that's when you can't assemble these by hand anymore. And you have to start thinking about how do you have somebody else do it. If you have 100, well, that's 2 or 3 weeks. If you have 1,000, that's a lot of friends and a lot of pizza and beer that you owe them.
Yeah, there's kind of an uncanny valley in manufacturing between what you can do in your basement with a couple of friends and like soldering irons and screwdrivers, and like the 10,000 units where you'd actually be able to get a contract manufacturer interested, and so that's So that's pre-sales, right? That's why pre-sales exists as a thing. It's why Kickstarter exists as a thing, is to help you get, it's not to get to the point where you can do 1,000, right? It's to get to the point where you can do 10,000 and begin to engage a contract manufacturer, right? So kind of be aware of that, what side of that you're on, right? It makes a lot of sense to do a prototype run where you can invite a bunch of friends over, pizza and beer, and get them to build them in the basement. But as soon as you start to get above that, you have to get way above that, right? And so there's kind of a cliff there.
And you can do all that locally. However, it is going to cost you 2 to 3x what it would cost for that 10,000 unit run. And really, for a large manufacturer over in China, they want to see something more like 10,000 per month, rather than just a run of 10,000. Because to create the new line, to invest in training their workers, they want to know that there's going to be constant demand for that product, because their factory is down during that changeover. So there's really, that is one of the biggest problems startups have, is these low runs as they're getting started, and finding a manufacturer that's willing to work with them when they haven't proven out their demand.
Yeah, so learn manufacturing, I think, is probably our advice on that one. It's kind of like learning to code and working at a software startup. Like, learn manufacturing if you're going to work at a hardware startup. So on the, what are we on to? So distribution?
So it's very hard, as we've covered, for startups to actually get the thing made. But after you've had it made, you have to figure out how you're actually going to get it into stores and how you get it to your customers. So even if you've done Kickstarter, you need to find a distribution partner and not lose all your profits in $20 shipping costs. So distribution is, I don't have a solid egg for that, or a golden egg for that either. It's sometimes just a matter of finding a partner near your manufacturer, sometimes FedEx, sometimes UPS, sometimes USPS, or if it's China, someone who will drop ship to a company and then distribute from there, who will actually send it out. And hopefully you can find someone who has retail channels for you into different continents and different stores. So looking for a partner that has contacts at Best Buy, at Radio Shack, or if it's soft goods with not with Lululemon, but some other clothing store.
Yeah. So I think one of the interesting things about hardware startups too, worth noting, is that when you get to the end of all of that cycle, so you've figured out manufacturing, you've built a prototype, you figured out manufacturing, you figured out your distribution. Because you're a hardware startup, you're probably not done. You're probably starting back at the beginning of that cycle and starting to work on your second product. So like, unlike software startups that probably build one product and continue to work on that one product over their life as a company, hardware startups build many products. So you're going to build a version 1, a version 2, a version 3, or you're going to build a whole different product line, right? So the Pebble guys are on to their second watch. The Ouya guys are planning a second console. There's this expectation. Fitbit has built 6 or 7 products at this point in time. Jawbone's built 30 or 40. There's this expectation that you're going to build many, many, many products, and that, especially if your revenue is tied to like a one-time sale of that product, for you to get more revenue from the same customer, you have to sell that customer a new piece of hardware, which probably is different than the piece of hardware you sold them last time.
Now, one thing that we haven't touched on is, why does China come up so much? Now, if you look at Silicon Valley is special for a couple of reasons. One, that's where the ideas are. There's an attitude there that I can make this idea happen. 2, there's talent. So the people who can make that idea happen, the data scientists, the UI designers, the product managers, they're all in Silicon Valley. Maybe not all, but there's a high percentage of them in Silicon Valley. And then 3, there's money there. So people who are not risk averse, who are willing to invest in speculative technology ideas, and that, in my belief, are the main things that make that ecosystem happen, and why Silicon Valley is kind of the hub of technology, of software technology. Now, for actually manufacturing and electronics, it would be Shenzhen. And the reason for that is that it's not just that there are a lot of factories there and a lot of workers there. It's actually that all the suppliers of all the parts are there. So if you need an LED for your product, wherever you make it, it's probably coming from Shenzhen. If you need a screen of some dimension, it's being made in Shenzhen. There are thousands of factories there, all with different capabilities, all with different levels of engineers, and different IP policies. And if you are located there, then you have direct access to those sources and those vendors, and you can work with them. And you don't have a long transit time between getting your LEDs, your screens, your plastic enclosures, and having your final product assembled and then ultimately shipped off. So even when you hear about companies building in the US or building elsewhere, they're shipping parts over from Shenzhen. And because Shenzhen has these large suppliers, there are actually these huge electronic markets in a place, specifically a place called Huajianbei, where you can walk around and you just see 16 square blocks of vendors with 50-story buildings filled with people all making almost the exact same part. And so you can find exactly what you need, and you can work with the vendor to get the lot size you need at the cost you need. And that is something, I was actually just debating with a fellow back there named Jim Stogdill, which center is more movable, Silicon Valley or Shenzhen? Like, which could be like the center of technology? And we kind of arrived at Shenzhen because there are physical factories there, whereas the ideas and the people can move in a way that those factories and suppliers can't. It's a pretty fascinating place. I recommend, if you're interested at all in hardware, that you go and check it out, and especially walk around Huajianbei. As Diana, who just made Amanda, who just successfully Kickstartered Clyde, an Arduino-based lamp, can attest.
That's a really good point.
Yeah, we've got about 8 minutes left, so.
Just curious about that. Like, when would be the best time to then approach the engineers or the manufacturers? If you understand, like, is this after product development, prototyping, or can they help through that process?
So there's a lot of really high level design for manufacturability and design for us. Oh, sorry. Yeah. So the question is, when's the right time to start talking to a contract manufacturer or a larger scale manufacturer? During product development or after product development, or at what point do you begin that conversation? And what I was going to say was there's a lot of really general stuff that you can do to make your product much more manufacturable, much more assemblable, and there's some really good rules of thumb there. But like Amanda was saying, at some point in time, you want to start talking with the factory. I'd say when you have your first, like when you have your prototype, you have a prototype, you can show it to people. You've probably printed out a couple of versions, but you're getting to the point where you're pretty happy with it. It's not perfect by any means, but like I'd say kind of in and around the point where you were, say, ready to do a Kickstarter or something like that, ready to show it to the world, ready to do pre-sales. I'd say somewhere in and around there. You could probably do it a little bit earlier if you knew that your next prototype run was just going to solve a couple of bugs and you already understood what those were. You could maybe do it a little bit before that, but kind of when the form factor is gelled, the general feature set of whatever it is has gelled. You don't necessarily need the software stack or anything like that. That would be my opinion.
Someone who's doing that right now is a fellow by the name of Joe Heitzenberg. He's out of Seattle, and he's got a Kickstarter going right now called Poppy. And what it is, a plastic device where you can slot your iPhone in, and it's just optical, so it's just mirrors that allow you to film and view 3D content with your iPhone. It's pretty cool. It's already 200% on Kickstarter. They've got maybe another half month going. But they went over to Shenzhen, went around, met with a bunch of contract manufacturers, been blogging the whole thing on iHack Things, that's the name of their blog. And they had built their prototypes out, found manufacturers that would work with them, and then launched their Kickstarter. and probably had guarantees in place that, okay, if we reach this demand, you'll give us these price points. If we reach this demand, you'll give us this price point. It helped that they had a fairly simple product. It's plastic, molded, and with an optical component, not electronics, but still fairly sophisticated. Renee?
Yeah, I'm curious. When you deal with the factories in Shenzhen, to what extent are they aware of Kickstarter and the likelihood that you might have a runaway success project?
Renee of OATV asked, to what extent are contract manufacturers aware of Kickstarter? I don't know for sure. The company I work for, all of them or some of them?
Some of them. Like if you start like seeing success on Kickstarter, they start getting in touch with you. Not at all. North American manufacturers won't get in touch with you. I think one got in touch with us, and we returned their email. They never got back to us. But like dozens of Chinese manufacturers will start emailing you.
I think the main thing that contract manufacturers want to see is demand and know that you're going to order a lot of units. So if you can prove that out, but it sounds like some will reach out to you if you do have a success.
So there's a public component to the design work that gets done on Upverter, and we see about a manufacturer a day reaching out for about a product a day on Upverter, wanting to take it and scale it and turn it into something. So we see about one a day.
What's your take on Chris Anderson's 3D robotics and leveraging Tijuana to make those drones? Do you see it as a trend, and do you see any other companies doing the same thing?
Well, certainly Apple is doing assembled in the U.S. And I mean, I think it's great for Chris. And MakerBot has their factory in Brooklyn. However,
Yeah, but
I don't know.
the manufacturing, all of it is done in Tijuana. It's on the other side of the border. It's designed in San Diego, but built in Tijuana.
Yeah, but my point was actually going to be, I don't know where the components come from. I bet they're being shipped across the ocean.
So I know Chris quite well. Part of the backstory on that is that his co-founder, the guy that runs operations at the company, is Mexican and from Tijuana. Okay, so part of it was that they spoke the language, and they could build a manufacturing team there at a tenth of the cost as it was going to cost in the U.S. But they're all reasonably educated. It's really close to where they want to run the rest of the company. But all of their raw material comes from somewhere else. Like they do injection molding other places. They get their parts from other places. It's really just an assembly shop.
Yep.
Sorry, any advice for getting high quality out of vendors in Shenzhen? So we worked with a couple. Samples are always awesome. Yeah. And then anything over 100, we've got a very high percentage of trash. Should we be expecting that? Okay, our profit margin should be 50% of that stuff we get is going to be trash.
Well, you will always. So he's asking about yields and what percentage. Like, do you always expect to have some failure rate? The answer is yes, you will. And depending on how good the manufacturer is, and probably more how much they care about your business, is how high that rate will be. But you always have to factor in some amount of failure.
Like what percentage would you say would be 50%?
I think the Pebble guys were only seeing 60% for a lot of their units, like 60% keepable. So they're getting better. They're getting better, but it's an aligning incentives kind of thing, right? Like you can make the manufacturer pay for the bad units. They're still going to have the bad units, though, right? Like you kind of have to look at the whole picture, right? It's can you make the process better so a higher percentage of the total manufactured goods survives, or who bites the cost? Or, is there an incentive for that line worker to do a better job? Could they do a better job, right? Is it a thing where somebody's doing a bad job? Or it's just a thing where we're going to build 100 and there's always going to be 40 of them that are crap? Because if it's always there's going to be 40 of them there's crap, just you have to build that into the cost structure.
No, it's like every order is an environmental disaster.
Yeah, yes.
So just a little bit, the company I work for sort of has a different model. It's PCH, which runs a number of large supply chains, and they actually act as the supply chain VP for companies. So if you want to go into China, you can actually contract them to find the factories. And there are a number of other companies that do this. And then they handle building out your line, watching the quality control, doing the distribution, and handling the retail afterwards. So you only have to go to China a little bit, not constantly, like what happened with Pebble and Aoya. So there are a number of different models. They're kind of the closest to AWS that I've found so far.
Yes, most of the hardware built in China mostly to have cost reduction. What would you say would be a sweet spot between the manufacturing cost and the selling cost? What would be the percentage sweet spot for you?
Like what kind of margin are you trying to have?
Generally multiply by 2.5 or 3 because you need to give it to you need to pay the manufacturer and the product costs, you need to pay the retailer, and then you need to pay yourself.
Because companies like Apple are trying to bring some of their product in the United States to say that it's built in California.
Assembled.
Assembled. But they're still keeping that kind of sweet spot also because they can't afford it. So sometimes if it's not necessarily to go to China, would it be a good strategy to build it in North America? If you keep the same percentage versus the manufacturing cost and the selling cost.
I mean, this is where we get into the Shenzhen ecosystem, that's where all the suppliers are. That's where all your parts are coming from. And so you're either trying to send your assembled product across the ocean, or you're sending all your parts across the ocean and then assembling. So you have to do a cost benefits analysis for you. And how important is it to have that assembled or manufactured label on your product versus having it be $10, $20, $50 cheaper?
Yeah, I think Brady's right. Just run the whole number, run the whole picture, right, and do what makes the most sense for your business. Do you want to be on a plane all the time? Can you charge more money? Just figure out. I think we're about to get kicked off. Cool.
All right. Thank you very much.
Thanks, guys.